In this video we will be taking a look at how you can actually show the next piece on the right here, and we will also be clearing some lines. So without further ado, let me just show you actually how the line clearing works. I messed it up, so never mind. Let's actually show you how the line clearing works this time without messing it up. I'll just make it very easy for myself here. And by saying that, I can't do it with this piece. So here we go. So as you can see, when we actually hit the bottom here, we will be clearing a line, and you can see the pieces fall down, and we can continue with our game. So this is what we'll be doing this video, so let's get right in. Okay, so first thing we want to do is we want to make sure we actually select a new piece and we actually show it like we did in the beginning here that I showed. So what we can do is we can actually do the same that we do right here in our start game, and we actually want to do the same for the next piece. So we can change this to next tetromino type, and we name this the next piece atlas, I think. Yep, we did. And then we want to make sure we actually use the next tetromino type in here instead of our current one. So that's pretty much all we have to do in the start new game. Then what we want to do is inside our initialize function, we want to also render the actual next tetromino on the board. So we can copy this line here and we paste it, but we just want to modify it to use the next tetromino type, the first index. And then we also want to set this to a certain location. In our case, I'll add it here, so it shows up at the top right of our board. Then, once we have done this, we want to move over to our move tetromino function. In here, we want to actually add an else. So if it's not a valid move, we basically do another check if the direction is downwards. And if it is, we want to length the tetromino, which is a function we'll create in a second. Then we want to actually update our current tetromino type to the next tetromino type, so that we have our next piece ready. We also want to do the same for the piece atlas. And then we choose a new tetromino for the next one, because we have actually updated it to the current tetromino type, so we want to also make a new one. Vector UI, and then we just search another one in our function here with the next tetromino type at index 0. And then what we want to do is we want to actually go ahead and initialize this. So we basically initialize our tetromino again, and later on I'll actually just add it right now. We also want to make sure we clear our next tetromino preview, because what will happen is if we actually start the game and we have the next piece on the top right, the pieces will overlap and they will show different colors. So that's why we want to clear the preview before we actually initialize the new tetromino. So then we want to make our length tetromino function. So we'll just do that right down here. Then we basically loop through all of the active tetromino pieces, and we want to remove it from the active layer and add it to the board layer, because the piece won't be active anymore, and we just want to print it on the board so that we have our active layer always set to the tetromino that's currently playing, kinda. So we just set that to the current position plus the I, and then we want to update the board layer. So we add the actual tetromino onto the board layer and we remove it from the active layer. So we add our tile ID and our piece atlas. So again, this removes it from the active layer and adds it to the board layer so that we don't have any conflicts when colliding or anything else. Then we want to make our clear next tetromino preview function, which will also just return nothing. So this will loop over every single block inside of our game not our game, sorry, or actually display, where we actually show the new tetromino. So what we want to do in here is we want to basically remove everything inside of this range. So how we do that is by simply passing the coordinates that is between these two ranges right here, and we just remove everything that is there, and then we can actually initialize our new tetromino and show it on the top right there. So we can actually already test this out. As we can see, we can now see the new piece in the top right here. So if we just place this one down, we will see that it actually detects our landing, so we actually get a new piece. So this happens every time, as you can see. Very nice, yes. So just one more example. You see it working, it's very nice. So that's already it for pretty much selecting our next piece here. So now we can actually get started with clearing the board. So what we want to do is we want to make a couple of functions, and let's do that right now. Alright, so for this we want to make two new functions. One is the check rows function, which will obviously do what it says. It'll check every row and actually see if we can see an empty spot, and if there's an empty spot we want to just continue, but if there's actually no empty spots in the row, we want to make sure we actually get rid of those rows, and we simply just move every piece down. Then we also have a function to shift these rows, which will be the second function that will actually do the logic of moving the rows down by one to make sure it's always at the bottom and doesn't hover above the bottom. So in our check rows function, we want to actually initialize a variable here that will be our rows. Then we want to simply loop over these rows in a while loop, so it keeps going as long as the rows are bigger than 0. And we want to set another variable called cells filled. And we want to now loop over our columns. And in here we want to use the helper function we made in the previous video. So if you haven't checked the previous videos out, please do so. I'll just have a pinned playlist at the top right of the video, so you can watch everything in the series so that you don't miss anything. So we use that function, so if not is within bounds, to basically check if it's actually a valid position we want to go to. So if it isn't, that basically means the cell is filled. So we actually add that onto the variable here. Then we want to go out of the for, and we want to simply check if the cells filled is equal to our columns. That would mean that the actual bar is full, or the row is full. And we can actually shift the rows downwards. And then in the else here, we simply remove one from the row. So that's the check rows function. Then in the shift rows function, we want to actually initialize an atlas, and we want to again loop over the rows, but in this case we want to loop over the row we have actually passed on as a parameter here. Then also the same but for the columns. In here we want to set the atlas to the coordinates we get from the board layer. So we do this by getting the cell atlas coords, and we want to pass our coordinates, which is the j plus 1 and the I minus 1. So what this will do is it will get the actual rows, and we have it save in the piece atlas so that we can actually move it, or I mean remove it and move it down. So what we do here is if the atlas is equal to -1 and -1, that basically means that the cell will be empty. So what we do then is we basically remove it from the board layer. J plus 1 and I. And if it's not empty, then we want to make sure we actually just set the piece onto the board layer. with the correct tile ID and our defined atlas up here. What do you mean? J is not defined in current scope. Ah yes, I didn't indent it. There we go. That has to be in the for loop. So that's the shift rows function. Now, pretty much to test this out, what we want to do is we want to come over to our move tetromino, and right before we select the next or current tetromino type, we want to check the rows. And like so, we will actually be able to clear an entire row. So let's test it out. Show some tetromino skills here. There we go. Ah, man, are you serious? I messed it up. I moved it last second. That's fine. We'll just do that piece right there. And we will just move it down this time. But let's make sure I actually do it correctly. Right. So then we do this. We can actually add this. Serious. As you can see, I only give tutorials. I don't really play Tetris. Whatever. As you can see right now, the line gets cleared and we actually move down one block or one block, and you can see every piece move down with it. So now when we actually want to clear another line, we need to get the right piece here. If we actually get it, we do. We don't. Oh well, you get the idea. We actually clear the line and that's working all correctly. So this was quite an easier video, or a shorter video. It's basically just some checks here to check if the row is actually clear or not, and if it's not, we simply clear the line and we just play onwards. So that was pretty much it for this video. In the next video I want to utilize the time to basically make a nice UI. So we want to actually add some score elements, we want to add a nice little box around this maybe, we want to start a new game, and so much more. But that's something we will be talking about in the next video. So without further ado, thanks for watching. Please like and subscribe, and if you have any tips or you have any problems, just let me know and I will help you out the best I can. So yeah, that was it, and I'll see you next time. Bye bye.